Question number 5 wants us to find the dimensions of the rectangle of the largest area that has its base on the x-axis and its other two vertices above the x-axis on the parabola y equals 8 minus x squared. So what we have here is a parabola following 8 minus x squared is going to go like this. And this point up here is going to be at 8. So now what we know is it's going to be a rectangle where it comes up to some point on the parabola on both sides and then across from there. So this rectangle is the one we're trying to optimize. So what I'm going to do is I'm going to call this point xy. Since we don't know where it's going to fall, that would make this point negative xy. That's going to make this x, this also x, and this y. So now, what I want is to maximize, because we want the largest, the area. So the area of this rectangle is 2x times y, and that's what we want to maximize. So to maximize that, we got to take the derivative, but before we do, we got to get it down to one variable and simplify. Well, what I know is y is 8 minus x squared, so this is going to be 2x times 8 minus x squared, and that's what we're going to attempt to optimize, which is 16x minus 2x cubed. That is going to be my function. So my derivative is going to be 16 minus 6x squared. So now from there, we want critical values. My critical values are when that's equal to 0. That's equal to 0 when 6x squared equals 16, or when x squared equals 16 over 6, which is 8/3, or when x is equal to plus or minus the square root of 8 over 3. So now, if I want the coordinate, because it says the dimensions, that's going to be half the width of the rectangle. So to get the other part of the coordinate, what I'm going to go ahead and do is plug this into my original 8 minus x squared. Squaring that is 8/3, so y equals 8 minus 8/3. 8 is 24/3, so that's 24 minus 8, or 16/3 for y. So now I have my x value and my y value. Those are my dimensions, or I can use those to get my dimensions. So the dimensions of my rectangle are 2 of the square root of 8/3, because it's 2x wide, by 16/3 tall. We don't have units within the problem, so we don't have to worry about those. But what we do want to do is justify our answer using the second derivative. The second derivative is going to be negative 12x. And since x is greater than 0, this is going to be less than 0, which is concave down, which is a maximum. So this is the answer to my question.